My dear students, in my previous video, I gave the definition of a matrix and how to define the elements of the matrix, and also I explained order of a matrix, and I have explained some simple examples also. Now in this video, I am going to introduce various types of matrices and some simple problems also I am going to solve now. There are some special types of matrices we have to see one by one. First, row matrix. Row matrix, a matrix is said to be a row matrix if it has only one row. A matrix is said to be a row matrix if it has only one row. This is the definition of a row matrix. A matrix is said to be a row matrix if it has only one row. Example: 1 root 3 minus 4 0. You see, this is an example for a row matrix. Here you have only one row, but 1, 2, 3, 4 columns. Therefore, the order of this matrix is 1 by 4. So, row matrix is a matrix which has only one row. One row and 4 columns may be as many columns as we have, but it is a row matrix. Only one row you have. Next, second one is column matrix. See, there is the same. A matrix is said to be a column matrix if it has only one column. If it has only one column. Column matrix. A matrix is said to be a column matrix if it has only one column. Example: 3 minus 1, 4, 1 by 2. Like that. Here also you have 3 rows and 1 column. Sorry, 1, 2, 3, 4 rows and 1 column. That is 4 by 1. A column matrix has only one column, whereas row matrix has only one row. Like that, row matrix and column matrix are defined. A column matrix is a matrix which has only one column. Next, third one, the square matrix. Third one is square matrix. A square matrix is a matrix in which the number of rows and the columns are equal. If the number of rows and columns of a matrix are equal, then it is said to be a square matrix. See, 1, 2, minus 1, 0. See, 2 rows, 2 columns. So it is a square matrix of order 2 by 2, or simply we can say it is of order 2. This is called square matrix. Similarly, 3 by 3 also we can have. Root 3, 2, 1 by 4, 0, minus 4, 7, 3, 2, minus 6. Like that, you have 3 rows and 3 columns, and this matrix is also a square matrix. In it you have 3 rows and 3 columns. So, square matrix is a matrix. It has one equal number of rows and columns. So, row matrix, second column matrix, and third one is square matrix you have seen. In this square matrix, I am going to use one explanation. This is first row, first element. A11 is first row, first element, first column, first row, first column element. This is first row, second column element. This is first row, third column element. Similarly, A21, A22, A23, A31, A32, A33. It is also a square matrix of order 3 or 3 by 3. We can simply say 3 or 3 by 3. See, it is the element, 7 is the element in the second row, third column, A2, 3. Like that, the elements are expressed there. See, this A11, A22, A33. See, this element A11, A22, A33 elements are called leading diagonal elements. A11, A22, A33. See, column and row number, column number, row number, column number, row number, column number are equal. AJJ or AII, like that. See, A11, A22, A33. This diagonal element, this is called leading diagonal elements. These elements are called leading diagonal. These elements are called leading diagonal. Leading diagonal elements. These elements are called leading diagonal elements, or simply this is called a leading diagonal. A11, A22, A33 is called a leading diagonal or principal diagonal or main diagonal, whatever it may be. You can say this is by leading diagonal, principal diagonal, or main diagonal, whatever it may be. You can call it as leading diagonal, principal diagonal or main diagonal. These elements are called leading diagonal elements or principal diagonal elements or main diagonal elements. And this is called secondary diagonal. A13, A22, A31. This is called secondary diagonal, and we are always considering only main diagonal elements for our consideration. So, why I am explaining this is, next our idea is diagonal matrix. So that I am going to explain what is a diagonal, and then I am going to give what is a diagonal matrix. Fourth one. Fourth type is diagonal matrix. Diagonal matrix. So a diagonal matrix is a square matrix. Diagonal matrix is always a square matrix in which, except the leading diagonal elements, all other elements are 0. See. Zero, 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 zero. So except the leading diagonal elements, all other elements are 0. This type of matrix is called a diagonal matrix. So a diagonal matrix is a square matrix. A diagonal matrix is a square matrix in which all the elements except the leading diagonal elements are 0. You see the definition from your book fully. I just explained. I need not write everything in the board. Just I am explaining what is a diagonal matrix. Diagonal matrix is always a square matrix in which the elements except the leading diagonal are 0. One more example, if you want to say this 3, 0, 0, minus 1. See, this is also a diagonal matrix in which the leading diagonal elements are there except that these two elements are 0. This is called a leading diagonal matrix of order 2 by 2. This is 3 by 3 like that. Diagonal elements are explained. Diagonal matrix is explained. Now, fifth one, unit matrix. Unit matrix or identity matrix. Unit matrix or identity matrix. It is called, otherwise called identity matrix or unit matrix. In which unit matrix or identity matrix is also a square matrix in which the leading diagonal elements are units, but all other elements are 0. That's all. Leading diagonal elements are 1, all other elements are 0, then this type of matrix is called unit matrix. It is denoted by I3, identity matrix of order 3. If it is an identity matrix or unit matrix of order 3, therefore it is denoted by I3. Similarly, I2, identity matrix of order 2 is 1, 0, 0, 1. It is identity matrix of order 2. The main diagonal elements are 1 except that the other elements are 0. So, this is the definition for unit matrix or identity matrix. Next, scalar matrix. So, a unit matrix is also a square matrix. Diagonal matrix is also a square matrix and unit matrix is also a square matrix in which the main diagonal elements are 1, all other elements are 0. Next, sixth one is scalar matrix. Scalar matrix. Scalar matrix is also a square matrix and otherwise it is a diagonal matrix. Scalar matrix is also a square matrix, particularly it is a diagonal matrix in which the main diagonal elements are same, all other elements are 0. That is called a scalar matrix. The main diagonal elements are same, for example root 3, root 3, root 3, like that. This is called a scalar matrix. The diagonal elements, main diagonal elements are same. For example, one more example I am going to give. Lambda 0, 0, 0, lambda 0, 0, 0, lambda. I can write. It is also a scalar matrix. Diagonal elements are same. All other elements are 0. This is called a scalar matrix. So, scalar matrix is a diagonal matrix in which all the main diagonal elements are same. Other elements are 0. Next, seventh one, zero matrix. It is simple. Zero matrix is of any order. All the elements are 0. In a zero matrix, if all the elements are 0, then it is called a zero matrix. It need not be a square matrix. Zero matrix need not be a square matrix. It may be of any order, but all the elements should be 0. Zero matrix, example, all the elements are 0. Example, 0, 0, 0, 0, 0, 0, like that. 2 rows, 3 columns is a zero matrix. 0, 0, 0, 0, 0, 0, like that you are right. It may be a column matrix also. All the elements should be 0, or square matrix also. This is of order 2 by 2. It is called a zero matrix. It is 3 by 2. It is also a zero matrix. Zero matrix is nothing but all the elements should be 0 in the matrix. Then it is called a zero matrix. Next, equality of matrices. Now I am going to give one new definition, equality of matrices. For that you have two matrices. You have, for explaining the equality of matrices, you have two matrices of same order. Equality of matrices. Equality of matrices. If the two matrices of same order, elementary they are equal. A is a matrix Aij of order, for example 3 by 2. B is also a matrix of elements Bij of order 3 by 2. See, A is a matrix of order 3 by 2, Aij. B is a matrix of order 3 by 2, elements of Bij. They are of same order and also elements are equal. That is, Aij equal to Bij for every I and j. That is the definition of equality of matrices. For every I and j, element wise they are equal. Example, 2 minus 1, 4, 5, 0, 7. This should be equal to 2 minus 1, 4, 5, 0, 7. These, they are of same order. They are of same order. Also, elements are equal. The same, elements are same, not equal, they are exactly same. Suppose this is, you can say A, B, C, D, E, F. It means A equal to 2, this means A equal to 2, B equal to minus 1, C equal to 4, and D equal to 5, E equal to 0, F equal to 7. This is element wise, they are equal. So two matrices are of same order or said to be equal matrices. Then they are of same order and also elements are equal. So this is the equality of matrices. So using all these ideas, we are going to solve the problems in our next video. Thank you.